statements many number of times, or to execute the statements more than once, we use looping statements. Yeah. So looping statements process with 4 steps. The first step being the setting and initialization of conditional variable, execution of statements in the loop. Thirdly, after execution of the statements within the loop, we test for the condition variable. Based on whether the condition variable evaluates to true or false, we are going to again repeat it. Before repeating, we are going to update the condition variable, sometimes incrementing, sometimes decrementing. Let me just try to close this screen here. Yeah. So based on the nature of control variable and the kind of values assigned to it for testing, the control expression, the loops may be classified into 2 general categories. The first one is called as counter controlled loops. The second one is called as sentinel controlled loops. Now, when we know in advance exactly how many times the loop will be executed, we use a counter controlled loop. Say, for example, you want to display n natural numbers, and n is defined, predefined. Then the loop is called as counter controlled loop, because you know the number of times the repetition that occurs is known in advance. In sentinel controlled loop, a special value called a sentinel value is used to change the loop control expression from true to false. Now, for example, say you are trying to read the data from a file and you want to know the end of the file. So you give a...
Excuse me, sir.
Yeah.
Sir, the other students, they are trying to join, but it's showing that the host will let you in soon.
Okay, there are already...
They are unable to join, it seems.
Now 40 students have already entered.
Okay.
We'll check the technicality later. Okay. Yeah. 42nd, the other student entered the discussion now. 44. Okay. Admit all. Yes, I've allowed everybody.
Okay.
Yeah. Okay. So the sentinel control loop, a special value called a sentinel value is used to change the loop control expressions from true to false, as I said. Now, the example that I can give you is when we are reading data from a file, and you need to know how many characters are present in the file. So you give a special value, or you fix a special value at the end of the file. Say it can be -1, it can be end of a file, a special character. And such variables are called as sentinel variables. Now, based on the type of loops, there are two types that is supported by C programming language. One is called the pre-test loop, the other one is called as the post-test loop or the exit controlled loop. Let's see what these looping constructs have for
Excuse me,
us.
sir.
Yeah.
Sir, what is loop, sir?
If you want to execute a set of statements more than once, we use C constructs called as loops. It is executed in an iterative way so that you can execute the statements more than once. Okay.
Okay, sir.
So let's come back to pre-test and post. Let me, yeah, pre-test test loop and post-test loops. In pre-test loops, during each iteration, control expressions is tested first, and only then the statements within the loop is executed. Now, during testing, if the control expression evaluates to true, only then the instructions are executed. If it evaluates to false, then the loop terminates. Very Whereas in post-test loops, in each iteration, the statements within the looping construct gets executed first, and only then the checking of control expression takes place. Now, due to this, the minimum number of iteration that your post-test loop performs would be 1, which means that it will execute the statement at least once before checking the condition. Whereas in your pre-test loop, the condition expression, the control expression is tested first, and only then, if it evaluates to true, the statements are executed. Now, if the control expression evaluates to false, first time, then it will not execute the statement even once. And that is why we say that the minimum number of iterations that your pre-test loop performs would be 0. Example for pre-test loops are while and for, whereas post-test loop is do and while. So this is the flowchart representation of your pre-test and post-test loops. Here you can see in pre-test, first thing is the checking of the condition. Only if it is true, the statements within the looping construct executes. If it false, it comes out. If the condition evaluates to false, the control comes out. It will not execute the statements within the looping construct even once. Whereas in post-test loops, you can see that the statements are executed once and then the condition is checked. If it evaluates to true, it goes back and executes the statement again, or else if it evaluates to false, it comes out. Now let's begin our understanding by exploring pre-test loops. So as I said, we have two looping constructs which falls under this pre-test category, while and for, whereas do while falls under the category of post-test. So let's begin with the first pre-test looping construct, which is called as while here. So this is how your while loop format is, or the syntax is. So you have the initialization statement, and then you have the while keyword, followed by the conditional statement, and we embed the statements that has to be executed in a loop within flower brackets, and then the remaining statements in the program follows. So here we can see the flowchart of while loop. You have the initialization statement first, and then followed by the conditional statement. If the condition evaluates to true, then the statements within the while loop will get executed until it is true. This goes on and on until the condition is true. If it is false, then the control leaves the while statement and continues with the next statement after the while statement. Okay, now let's start off with a simple program to generate numbers from 1 to 20. So since we are using while, we need 3 parts. We just saw those parts in the previous slide. Let me just again go back and reiterate. Initialization statement. Then you have a conditional statement to check. And then you have an updation statement. Now this updation statement makes sure that at least for once the condition will evaluate to false, so that the control comes out of the while loop, or else it becomes an infinite loop. This updation statement can be either incremental statement or a decremental statement. Let's come back to the program that generates numbers from 1 to 20. So as we discussed, while loop has 3 parts: initialization statement, test condition statements, and finally update statement. So in this program, we are supposed to generate numbers from 1 to 20. From 1 to 20. So what would be the initial value and the final value? Initial value is 1, final value is 20. So initial value is 1, final value is 20. Now update statement. So is a common difference. What is the difference here? It is 1 between the numbers. So I'm going to update this value by 1 to generate the second value. Again, increment this value to generate the third value, increment this by 1 to generate the fourth value, and so on up till 40. So the difference between these two will be the update value. So here we can see the main function. This is the initialization statement. Here we can see I'm declaring a variable called a, which is of type integer. I'm also initializing it to 1. So this is the while loop. It's a keyword while followed by the condition, and whatever statements that we would like to execute in the loop will go into these flower brackets. This is called as a block of statements. So what I want to do in this program is to display 1 to 20, incrementing these values by 1. So since I have initialized a to 1, I will your while will check for this condition first. Why will it check for this condition first because it falls under the category of pre-test condition. Okay, so it will check whether a, that is 1, is less than equal to 20. Is the condition true or false? Obviously it will be true because a value is 1. 1 is obviously lesser than equal to 20. So the control goes in. It will execute the statement, print f statement. Print f a. What is the value of a? It is 1. So it will print 1. Next statement is the update statement. Here we have an incremental statement. A is equal to a plus 1. So 1 plus 1 becomes 2. Again, the control goes back. Now, remember, this is a unique type of a statement in C, which we call it as a looping construct or a repetitive statement. So it goes on executing the body of the while until this condition evaluates to true. Once it evaluates to false, the control comes out of this while loop. So what happens in the second step? A is got incremented to 2, goes back, checks 2 lesser than equal to 20. Again it evaluates to true, prints the value, increments A again. This time it is 2 plus 1, 3 is assigned to A, goes back to while loop, 3 lesser than equal to 20. Yes, it is. So it comes back, comes within the while loop, executes the statements within the while loop once again. So now it will print 3. Next value of A becomes 4. So this goes on printing values from 1 to 20. Once the value is 20, once after incrementing A becomes 20, goes back, checks 20 lesser than equal to 20. Yes, it is. It is equal to, right? Lesser than or equal to 20, it is 20, right? It will print 20. Next, A value will become 21 because 20 plus 1 is 21. A becomes 21, goes back to the while loop again, checks for the condition. This time it is 21 less than equal to 20. It fails. Condition evaluates to false. When it evaluates to false, the control comes out of while loop. Here you don't have anything. The function ends. The control comes out of your program. So this program basically prints natural numbers from 1 to 20. Is it clear?
So, in the
Yeah.
updation statement, can we use a plus is equal to 1?
Yeah, very well. Yes, you can use that.
Okay.
Any type of statement, that is fine, which increments a by 1 is allowed. In fact, here we have incremented a by 1. You can also print values from 20 to 1. In that case, you have to decrement. You say a equal to minus 1. That also works. Okay. Yeah. Next program. Now, please remind me about the timing. It goes on because I have to wind up the class by, I think, 10, right? We started, when did we start? We started by 9:30. So I can take class only up till 10:10. So just remind me if I'm exceeding the time limit.
Okay, sir.
Yes. So the next program is to generate numbers from 50 to 100. In the previous program, we generated numbers from 1 to 20, but here we are generating numbers from 50 to 100. So what would be your initial value of the variable? Obviously, it will be 50 because we are starting from 50, right? So in the program, here we can see integer a is equal to 50. We have initialized and declared a as an integer. Here we have a while loop. And in this program, we are not we are not able to see the flower brackets. There's no flower brackets here. Now we don't use flower brackets because there is only one statement as the body of your while loop. Yeah, there is only one statement. It's called a simple statement. Only one statement in the while loop. So you need not embed this statement within flower brackets. Number one. Number two, in the previous program, we had two statements. One statement basically printing the value of A, and the next statement, which is incrementing the value of A by 1. Now, this statement here in this program does both, because it prints the value of A and at the same time increments the value of A. There's a lot of noise, right? I think I have to mute. Yeah. Okay. So the initial value of A is 50. The condition that we need to check is A less than equal to 100. So what will be the first value of A? It is 50. So 50 less than equal to 100. It will condition evaluates to true. Printf statement executes. Next, A value becomes 51. 51 is checked with 100. Yes, 51 is less than or equal to 100. Again, it is true. Comes back to the statement, executes. So this goes on and on. How many times? 51 times it happens. And when A crosses 100, that is when A value is 101, the condition fails in the while loop and the control comes out of the while. So this is how we generate numbers from 50 to 100. Yeah, this is another example where we are trying to display numbers from 2 to 100, but this time you should observe that the,
Excuse me, sir.
yes.
Sir, in the previous program,
Yeah.
Like in the printf statement, after giving the data type, like after %d,
Yeah.
we even write like ampere A or just A. But here we are just writing A plus plus. So won't it just increment the value and straight away write it instead of already like here, while in the first set, it should
Yeah.
print 50. Won't it just print 51 because we have assigned as
Okay.
A
This
plus
is post increment statement. See, we have seen two types of increment statements. One is pre increment, the other one is post increment. Now this is post increment statement. What happens here is your initial A value is 50, conditions is checked, it evaluates to true. Can you all guys just mute your sound so that I will not be able to hear any of the sound? It is actually disturbing. Yeah. Whenever you would like to ask questions, you can unmute and talk to me, pose questions. And after I answer, please mute it once again. Okay. So A value is initially 50. That 50 is passed on to your printf statement. And after passing the value, A gets incremented by 1. Now, you are right. If I would have written this as plus plus A, it will first increment A value, making it 51, and the first value that gets printed will be 51. Right? Now that is
Oh,
called as
so
post increment statement.
So like we usually write ampere A or just A.
Ampersand A is it?
So yeah, so won't that be necessary here?
No, ampersand is
Like
to,
%d just holds the type of data we are inputting.
yeah.
So when we write A, it gives the value to that and it prints.
Yes, ampersand is
So
to represent the address. And
so won't that be necessary here?
no, it is not necessary here because you use ampersand in your scanf statement, not in your printf statement. If you are using ampersand in the printf statement, then you will expect the compiler to print the address of A, not the content of A. Here we want to print the content of A. The content of A is 50 in this case. So we want only 50 to be printed. So we usually don't use ampersand in printf statements. Only when we need the address of A, we use ampersand. Otherwise, we don't use ampersand in printf statements. Hope I have
Okay, sir.
answered your
Thank you.
point. Yeah.
Oh, yes, sir.
So the major difference between this program and the previous program is obviously the initial value. It starts from 2. And if you see the difference between the two consecutive numbers, it is 2, not 1. So instead of A equal to A plus 1, I will be using A equal to A plus 2. Okay. Otherwise, it's the same code. There's not much difference. So similarly, if I want to print multiples of 5 starting from 5, I would just replace this by A equal to A plus 5. Okay, and so on. This is a program which will generate numbers from 100 to 1 in a reverse order, of course, right? So the initial value is 100. So you can see here, initial value, I have initialized 100 to A, and the final value would be 1. So that is the condition that I'm specifying. If A is greater than or equal to 1, printf statement, and I'm reducing these values by 1, right? So I'm decrementing A by 1. So the first element that gets printed would be 100. 100, it will check 100 less, 100 greater than equal to 100, 1, yes it is. So it will print 100. Then it will reduce A by 1. Now the value of A is 99. It will come back, it will check 99 greater than equal to 1, yes it is. So again it will print 99. So this continues until A is reduced to 0. Even for 1 it will work. Once A is reduced to 0, it goes back, checks A, that is 0 greater than equal to 1, it fails. When the condition fails, it evaluates to false, and then it comes out, the control comes out. The control comes out, and the printing of values will stop here. Okay, now here I am printing the values from 10 to 100. If you see the difference, it is 10. So again, I have an initialization statement, condition statement, incremental statement. Incremental statement is by 10. So I'm incrementing A by 10. Guys, you need to clear this. Okay, the next program, it's not just printing the values from 1 to 100, but we are trying to find the summation of n natural numbers, and n is 100 here. So we need to find the sum of 1, 2, 3, 4 up till 100. So previously we printed the value, but here we are not supposed to print, we are supposed to find out the sum. So here we can see that the initial value is 1, final value is 100. So I have the same condition, A less than equal to 100. Now every time this iterative loop is executed, I am going to add these values to sum. How do I do that? Sum equal to sum plus 1. Initially sum value is 0. I have initialized it to 0. So it will contain 0 in it. So 0 plus the first value of A is 1. So 1 plus 0 is pushed into sum. So sum will be just equal to 1 now. Now I am incrementing A value by 1. What is the value of A now? It is 2. Okay, goes back, checks for A less than equal to 100, 2 less than equal to 100. So since you have 2 here, condition will again evaluate to true. So 2 plus the previous value of sum, 1. 1 plus 2 is 3. 3 is pushed into sum. A value was 2, now it will increment to 3. goes back, checks the condition, yes it is true, again it comes back. So sum was 1 plus 2, now it is 3. So 1 plus 2 plus 3. So this continues until A is 1 not 1. So by that time, it would have added 1 to 100 and placed that value into sum. And one very important thing that we need to observe in this program, the printf statement is outside the while loop, which is very important to note, because if you put this printf statement within the while, every time as and when you go on adding the values to sum, it goes on displaying. So you will see 100 values displayed as part of sum. So you should not do that. You have to just put your printf statement outside so that it will print only once. So sum equal to whatever value that it would have generated after adding 1 to 100 will be just displayed
Sir,
here.
sir, I
Yes.
have a doubt that what is the meaning of giving this modulus operator along with D?
This is the formatted string that we have here. See, we want to print integer value here. What is that integer value? It's a summation of 1 to 100. And printf is a function. And if you just go back to my previous videos, I have a the format of printf is prescribed. So you have control string followed by the arguments. So what goes into the control string? Obviously the string with some format code, that is here it is %d, where d represents an integer number. So I am trying to basically print an integer value. So it is percentage. That is why I'm using %d. I can also use I, which represents integer. I can also use u, which represents unsigned integer. Okay.
Means, sir, instead of using D, we can use U or I.
Yes. I've given you a list of such format specifiers. You can just check it out. Okay.
Okay, sir.
Yeah. Now this is another program. Can anybody tell me what will be the output of this program? The initial value of A is equal to 1. Sum is equal to 0. Here I'll check the condition whether 1 lesser than equal to 4. Yes, it is. So control goes in. It will print sum and A. What is sum now? It is 0. What is A? It is 1. So 0 and 1 will be printed. Now here I am trying to find the sum. Sum 0 plus 1 is 1. So the next value of sum becomes 1 and A value becomes 2. It will check here. 2 less than equal to 4. Yes, it is. So sum, the previously calculated value was 1. It will print 1 here. And A value is 2, it will print 2. So this goes on until A gets incremented to 5. Once it increments to 5, the condition evaluates to false and the control comes out of this while loop. It will print sum as well as A. So this is the output. So this represents sum, this represents A. So here you can see every time how sum is calculated. Sum is nothing but the addition of A. So A, you can see 1, 0 plus 1. Then here this is 3, right? 1 plus 2. Here it is 6, right? So 1 plus 2 plus 3 is 6. And so on. It goes like this. I think this would be the last program that we will discuss today. Void main. Again, the initial value of A is 2. Sum is 0. It will check the condition. Condition evaluates to true. Sum is equal to 0 plus 2. A gets incremented. prints the value of sum and a. So this continues until a increments to 7. Once it reaches 7, it will stop. Right? Once it reaches 7, it will stop. By the time some value would be 20. A value is 7. Is that fine? So next class we will just go through a few more programs and take up other control looping constructs. Meanwhile, I think today I will be uploading assignment questions. I want you all to execute those programs on maybe online compilers or on Ubuntu and submit those programs as assignments. I will give you the format in which you need to store the files. Create a folder and dump it in the Google Drive. Okay. So any doubts, as usual, you can post it on the WhatsApp group so that I can get back to you in the next class. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you.